integrate arcsine of x dx. So I think this integral is not the most obvious to know how to approach, but you might be looking at that arcsine of x and thinking of its derivative. And we could use it to help us find the antiderivative of arcsine of x. So if I want to use that derivative of arcsine of x, let's do integration by parts, where I have my u part here that I want to take the derivative of so that I could plug into this form. Sorry, v du. So let's start assigning what our u and dv and v values are. So we said we would want to have it as arcsine of x because we know the derivative of it, which is 1 over the square root of 1 minus x squared dx. And if you did not know that that was the derivative of arcsine of x, then you could just do the derivative over here and derive it implicitly, and you should come to the same conclusion. And so now we must assign our dv, and since we have our integral in this form, what we decided is going to be u. Whatever is left over is going to be our dv. In this case, it's just dx. And our v is going to be what the integral of our dv, which is just x. Another way you could figure out what that u is supposed to be, if you didn't know, is to use the acronym LIATE, where L stands for log, I stands for inverse trig, A stands for algebra, T stands for trig, and then finally E stands for exponents. And it kind of goes in order of what you want to prioritize as your u, and I is the first one here. But I think the explanation I did in the beginning had, could be more helpful because not every integral by parts you can apply this acronym to. So it's good to reason. Anyways, so now that we have everything assigned, we could start by plugging it into our integration by parts formula. So u times v is just x arcsine x minus the integral of v du, which is x over the square root of 1 minus x squared dx. Now I could integrate this part over here, and the way to integrate this one is just going to be a simple u sub because I have a function and its derivative up here. With some manipulation, it's going to be its derivative. So I'm gonna use a different variable because I already used u and I don't want to get confused. So I'm going to do a t substitution. So t is equal to 1 minus x squared. And so dt is going to be equal to negative 2x dx. And now I want that dx side to look like what I have in my integral, so I will be multiplying by negative 1/2 on both sides, so that could isolate that dt, so I have x dx on the right hand side. Now I can rewrite my integral in terms of u, so keeping that x arcsine x the same, nothing changes. I can pull out this constant so that this negative turns into a plus. 1/2 the integral of 1 over u to the power of 1/2, or you could rewrite this as, not u, t, t to the power of negative 1/2 dt. And now I could just integrate this part using the power rule. And so again, that x arcsine, x doesn't change, that constant also doesn't change. And now I'm going to have negative 1/2 plus 1, which is t to the power of 1/2, all divided by that new power, 1/2. So I know that these two will cancel out. Also, don't forget to add the arbitrary constant c. Those two will cancel out, so I'm left with x arcsine of x plus the square root of t plus c. Substituting that t back in, I have x arcsine x plus the square root of 1 minus x squared, right? Plus c. And that's it.